Yes, boys. I hope all are you knowing that there are four basic tissues of the body: epithelial tissue, connective tissue, muscular tissue, and last is nervous tissue. You have gone through the epithelial tissue, connective tissue, not the muscular tissue, or yes? Good. The last one, basic tissue of the body, nervous tissue. I will talk today about the nervous tissue. Nervous tissue of the body is a specialized tissue of the body. The point is this: why we say that it is a specialized tissue of the body? The reason is it receives the information from all the parts of body, and not only all the parts of the body but also receive the information from the surrounding. All these information from the different parts of the body or the surrounding reach to the central nervous system. The central nervous system analyzes the information. What happens? Why don't you take the other place? Why are you so much congested? इतनी जगह खाली पड़ी है, कहीं भी बैठ जाओगे. And after the analysis, the central nervous system pass the order, and that order reaching to the effector organs or the muscles or the joints that carry out this. Suppose I put my hand here. If there is a hot place, the information goes to the brain. Brain analyze that information and give the order, take out your hands. So all these things, they are done by the nervous system. Because of this, the nervous system is called specialized system of the body. Similar to other tissue of the body, nervous system is also consisting of nervous tissue. Nervous tissue is having two type of cells, neurons and neuroglial cells. The neurons are fixed amount, and the other important part is neurons does not undergoes mitosis. The mitotic division is not taking place in the neurons. Because of that, if there is a damage of the neurons, neurons will not regenerate. Listen very carefully. Neurons does not undergo mitotic division, and because of that, there is no regeneration of the neurons. Once the neurons damage, that will not regenerate. Besides this, or opposite to this, neuroglial cells under mitotic division, and there is replacement of the neuroglial cells. Alright, and neurons are the main important part of the nervous system. So, because of that, we say that neurons are the structural and functional unit of the nervous system. It is a structural and functional unit of the nervous system. Alright, I just give you two ideas about its development. Nervous system begins to develop in the third week of intrauterine life. Third week of intrauterine life. What happens? That you have gone through the ectoderm. Don't keep yourself down. What's problem? The central part of the ectoderm is thickened, and this thickened central part of ectoderm is called neural plate. This neural plate later on it forms the tubular process. That means first of all it remains as a plate. Later on this plate is transformed into tubular form. That is called neural tube. From this neural tube, both the part of nervous system, central nervous system and peripheral nervous system develop. One thing. Suppose this is the neural tube and the peripheral part of the neural tube, that means on this side, on this side. These parts are forming the neural crest cells. The diagram is showing the neural crest cells, and these neural crest cells they give rise development all these things. You can see here we will talk like this, the different type of the neuron and also the sympathetic neuroblast, the ganglia and these things. And on these sides you have gone through the covering of the brain in previous classes also. Outside is the dura mater, then pia mater, then arachnoid mater. Out of these, the arachnoid matter and pia matter, they also develop from the neural crest cells. And similarly, the melanocytes of the skin, that is also developed from this. I will talk about the part of the ganglion, the peripheral part of the ganglion, Schwann cells, which are forming the myelination, and these, all they are developed from the neural crest cells. Okay. After knowing this, what happens? That the nervous system, we divide the nervous system into, anatomically we divide this into three parts: central nervous system, peripheral nervous system and autonomic nervous system. The central nervous system includes the part of brain and spinal cord. Brain is located in the cranial cavity, while the peripheral part, the spinal cord, is located in the vertebral column. These two, that is the brain and spinal cord, they put under the head of central nervous system. And all the nerves which carrying the information from peripheral part or outside, they reaching to the central nervous system. These are called afferent nerves, afferent spinal nerves or the sensory spinal nerves, and the order given by the brain reaching to the effector organ, they are called the efferent nerves or the motor nerves of the spinal nerves. Besides the spinal nerves in the bodies are about 31 pairs of the spinal nerves. Besides the spinal nerves, the some nerves are coming from the brain. These are coming out cranial cavity. Brain is located inside the different part of the body. Twelve pairs. So all these cranial nerves and spinal nerves are the part of peripheral nervous system. Autonomic nervous system. Now listen, we use the word autonomic nervous system. Autonomic nervous system is self-controlling nervous system. But there is a guider over this, because nothing is left independent. No doubt, the part of the diencephalon, which I will tell you just now, that is the hypothalamus. Hypothalamus, the part of the brain, is control, analyze or regulate the autonomic nervous system. Previously, we were saying that autonomic nervous system is not under the control of central nervous system. But recently, the hypothalamus is correlate or regulate the control of autonomic nervous system. Autonomic nervous system is again dividing into two parts, sympathetic part and parasympathetic part. The parasympathetic part is the normal habits of the body, digestion, blood pressure, heart rate, respiration rate, all these are regulated by the parasympathetic part. And to differentiate, in parasympathetic part, there is a constriction of the pupil. Just reverse through this sympathetic part of the autonomic nervous system, that is also called fight and flight system of the body. In this part, the body is requiring more energy, and because of this more energy, the sympathetic system and it activates when the sympathetic system is activated during emergency. There is how we differentiate that the sympathetic activity. The heart rate increase, respiratory rate increase, and pupil dilate. All these activities they increase during the sympathetic activity and due to stimulation of sympathetic system. Right? This is just where the part which I just introduced you. Now take the different parts starting from the development. Look this diagram. The neural plate, the cranial part of the neural plate. I have told you what is the neural plate. In the beginning, in the third week of intrauterine life, the central part of the ectoderm thickened, and that thickened part is called neural plate. The cranial part of neural plate, that means close to the head side. That part developed into the brain. So see the diagram. This cranial part of the neural plate thickened, and that gives rise development to the central nervous system. What are the part of the central nervous system? Brain and spinal cord. See the part. The brain is again differentiating into three parts. Prosencephalon, anterior one or cranial one, prosencephalon, middle one is called mesencephalon, and posterior one or caudal is called rhombencephalon. The prosencephalon, see the diagram, then write. Prosencephalon again dividing into two parts, telencephalon and diencephalon. Telencephalon gives rise development to the cerebrum. Telencephalon gives rise development to the cerebrum, and the cavity of it is called lateral ventricle. See this diagram. The telencephalon, this one, is giving rise the two processes on the both the sides, left and right. I am talking of these processes. These are the lateral ventricle, that is the cavity of the cerebrum. That is called lateral ventricle. Alright. Now look the diencephalon, which is also the part of prosencephalon, and diencephalon forms the thalamus and hypothalamus. Thalamus and hypothalamus are the part of diencephalon, and the cavity of the diencephalon, that is this one, that is the third ventricle. This is the third ventricle. So third ventricle is the cavity of diencephalon. Lateral ventricle is the cavity of cerebral hemisphere. Now come down. The mesencephalon. Mesencephalon gives rise development to the midbrain. Forebrain we have talked telencephalon and diencephalon. Telencephalon gives rise development to the cerebral hemisphere, and diencephalon gives rise development to the thalamus and hypothalamus. The midbrain develops from the mesencephalon, and the cavity of the midbrain Look here, that is called cerebral aqueduct. Cerebral aqueduct. That is the cavity of the midbrain. Alright. Now see the third part, rhombencephalon. The rhombencephalon again divide into the two parts, metencephalon and mesencephalon, myelencephalon. The metencephalon, that is this part, gives rise development to the part of cerebellum and bones, and myelencephalon gives rise development to the medulla oblongata. So that is the way how the brain develops. Should I repeat? No? Okay. This you will read again in the embryology, but later on, very late. I just give you idea that how the brain develops, and you must know the different cavity of the brain. Brain is having the three cavities. Lateral ventricle, a pair of the lateral ventricle, because there are cerebral hemisphere on the left side and right side, and both the cerebral hemispheres are connecting with the fibrous tissue that is called corpus callosum. Each cerebral hemisphere is having the cavity lateral ventricle, and the cavity of the diencephalon, that is third ventricle, this one. Similarly, the midbrain, the cavity of the midbrain is cerebral aqueduct, and the cavity of the part medulla oblongata, and here the fourth ventricle. So these are the three cavities of the brain. After seeing this, we divide I speak first central nervous system, peripheral nervous system. Now look here, this is the classification. Anatomically, we divide this central nervous system, peripheral nervous system. Central nervous system consisting, again dividing into the brain and spinal cord. Both are the part of CNS, central nervous system. And look here, the peripheral nervous system, as I told you, having the nerves. Nerves are two types, the spinal nerves, peripheral nerves. Peripheral nerves, again you divide this into the cranial nerves, 12 pairs, the spinal nerves, 31 pairs, and autonomic nerves, splanchnic nerves, that is autonomic nervous system. This classification slightly differentiates. The physiology, they use this classification. I have the latest one. We divide the nervous system into the three parts, central nervous system, peripheral nervous system, and autonomic nervous system, which you can see here in the part of functional aspect. The somatic, autonomic. Autonomic, again dividing into the sympathetic, parasympathetic, and sympathetic, again having dividing into dorsal root ganglia, autonomic ganglia, that I will come just now. Look this diagram. Brain is located here in the cranial cavity, and this is the vertebral column where the spinal peripheral nervous system is located. Now see this nervous tissue. Nervous tissue, it is consisting of, as I previously told, neurons, structural and functional unit. There are two types of cells in the nervous tissue. One is the neuron, another is neuroglial cells. Okay. The neurons are the important parts of the brain, which are named as structural and functional unit of the brain, and they didn't go mitotic division, so there is no regeneration of the neuron. Second thing, as everything requires the nutrition, protection, and support. As the neurons are so important part of the brain, they require the nutrition and support. So these nutrition and support of the neurons are provided by neuroglial cells. So what is the function of neuroglial cells? They provide the nutrition and support to the neurons. Okay. After seeing this, now we will discuss the different type of the neuron and different type of the neuroglial cells. First of all, see the neurons. Neurons can be classified in various ways. First of all, see on the process how many processes neurons are having. The neurons, they are having the cell body, and the cell body is having the same feature: nucleus, nucleolus, mitochondria. Look here, nucleus, nucleolus, and also the rough endoplasmic reticulum and these things. Nasal bodies, you can see the nasal bodies and lysosome, Golgi bodies, all these things. The important part, look this cell body. Here you are seeing the short processes which are dendrites. These are named as dendrites, and a one long process, axon. So point is this, we classify the neurons on the basis of that how many processes it are having. Definitely the axon is single. Keep this thing in your mind. Axon is always single. Only the number of processes will be differ in dendrites. In body, there is one neuron, unipolar neuron, that is present only in the mesencephalic nucleus of trigeminal nerve, nothing else. So keep this thing in your mind. If the examiner asks you which is the unipolar neuron, mesencephalic nucleus of trigeminal nerve. Then there comes the bipolar neuron. Bipolar means two processes. Definitely one is axon, another is dendrite. Understand? And the bipolar neuron in the body, the things which I am telling you just now, very important. So you should keep this thing in your mind. Bipolar neurons are present in the retina of the eye, and the ganglion of the vestibulocochlear nerve or the eighth cranial nerve, vestibular cochlear nerve. मैडम जब लिखने के लिए कहूँ तो बैठे हुए शक्ल क्यों देख रहे हो? Why don't you write? Bipolar neuron present in the retina of the eye. Second is the vestibular cochlear nerve. In bracket you can write the eighth cranial nerve. Eighth cranial nerve, vestibular cochlear nerve. The eighth cranial nerve, it is having the two parts, vestibular part and cochlear part. Cochlear part is for listening, the hearing for the sound, and vestibular part is for maintenance of balance. Then multipolar neuron. Multipolar neuron present in most of the part of body, nerve fibers and nervous system. Multipolar neurons, maximum part of the nerve fibers, it is multipolar. Then another comes pseudo-unipolar. Whenever we use the word pseudo, means false. Pseudo-unipolar neuron, which is having the single process. And this single process, look here, T-shaped process. This is the T. Understand? Pseudo-unipolar neuron means the T-shaped process comes out from the cell. And this T-shaped process then divides into, one is forming the dendrite, acting as a dendrite, another is acting as axon. Because of this is called pseudo-unipolar neuron. And this pseudo-unipolar neuron is present in dorsal root ganglion that I will tell you just now. बहुत सीधी बात है मैडम, क्यों परेशान हो रही? I am telling you girl, pseudo-unipolar neuron is having the single process. Because of this it is called pseudo. And this process divided into two parts. One of them is acting as a dendrite, another is acting as axon. And this is present in dorsal root ganglion of the spinal cord. Now look here. We have talked unipolar neuron, pseudo-unipolar neuron, bipolar neuron, multipolar neuron. So this classification is on the basis of number of process. Second is on length of the nerve fiber process. The length of axon is always longer, and if the length of the axon is more longer, it is called Golgi type of 1, Golgi type 1. And the Golgi type 1 fibers are the tracks which are coming from the brain are under the head of Golgi type 1. Golgi type 1 neurons are those which are very long, and the tracks which are coming out from the brain are under the head of Golgi type 1. Why? Because their length is longer. Golgi type 2, these are the fibers having the short length. They are example are interneurons. Then we classify the neurons on the basis of their function. Look here. If the neuron is bringing the information, carrying the information from different parts of the body or periphery to the central nervous system, these are called sensory neuron or afferent neuron. If they are bringing the information from central nervous system to the effector organ, they are called the motor neurons. So on the functional aspect, we classify the neurons, motor neuron and sensory neuron. And the third one, as I spoke, we just named interneurons in between these two. Then I come to the part of neuroglial cells. The neuroglial cells, they are again classified into different types. In the central nervous system, the following neuroglial cells are present. These are astrocytes, oligodendrocytes, microglial cells, ependymal cells. All these are present in central nervous system. In peripheral nervous system, there is present the Schwann cells and satellite cells. Schwann cells and satellite cells in the peripheral nervous system. Now, I am telling you one by one. Look the astrocytes. Astrocytes, they are star-shaped, and again they are of two types, fibrous astrocytes and protoplasmic astrocytes. The fibrous astrocytes, they are present in white matter of the central nervous system. As we know that these are the neuroglial cells of central nervous system. So definitely fibrous astrocytes also present in the CNS. The second one also present in the CNS. But the fibrous astrocytes, they are present in white matter of the central nervous system, while the protoplasmic astrocytes, they are present in the gray matter. Function is the same, providing nutrition and support to the neuron. Then come to the part of oligodendrocytes, very important. Before that, you have noticed that electric wires, The electric wires are of two types, coated and uncoated. Okay, coated and uncoated. The coated wires are better for the conduction of the electricity, also acting for longer time. Similarly, the nerve fibers of the brain are myelinated and non-myelinated or unmyelinated. The myelinated nerve fibers, definitely the preganglionic fibers that we will type in the sympathetic system are myelinated, and the maximum part of peripheral nervous systems are myelinated. They help in conduction of nerve impulses very fast in the myelinated compared to the unmyelinated nerve fibers. Alright, forget this. At present, our basic point is the myelination of the nerve fibers in central nervous system is carried out by oligodendrocytes. And that is very important function of oligodendrocytes and commonly asked in the exam. Myelination of nerve fibers in the central nervous system is P, oligodendrocytes. In peripheral nervous system, the myelination is done by the Schwann cells. And this is the common function of the examiner. The myelination of the peripheral nervous system is by Schwann cells, and in central nervous system by the oligodendrocytes. See the next one, microglial cells. These are phagocytic cells. Phagocytic cells are those cells, if by the way foreign particles or the foreign bodies enter, they engulf, पकड़ लेते हैं and start destroying. Understand? Microglial cells acting as a phagocytic cells. Phagocytic cells means if any foreign bodies comes, they engulf, पकड़ लेते हैं and destroy. That is the function of microglial cells. Then ependymal cells. As previously I told you, there are how many cavities? 4. The cavities, whatever it is, whether lateral ventricle, third ventricle, fourth ventricle, or cerebral aqueduct, their wall are lined by simple columnar cells. Suppose this is the cavity, this is the wall. The wall is lined by the simple columnar cells, and these simple columnar cells are the ependymal cells. So ependymal cells are forming these are the simple columnar cells, and they are forming the cavities of all the ventricles, lateral ventricle, third ventricle, fourth ventricle, or cerebral aqueduct. Then one is left, satellite cell. As I will talk about the ganglia are the neurons cell bodies which are present outside the central nervous system. Ganglia are the collection of the neuron cell bodies outside the central nervous system. And these ganglia are sympathetic ganglia, parasympathetic ganglia, dorsal root ganglia, all these. But these satellite cells, they are flattened cells, chapte. These are the flattened cells lining the dorsal root ganglion or the sympathetic ganglion. They surround the neuron of dorsal root ganglion or the sensory, the sympathetic ganglion, not the parasympathetic. Flat cells. So they are a protection of the neurons as well as part of conduction of the impulse. These are called the satellite cells. So these are the different type of the neuroglial cells. Now look this diagram. I am talking of the axon. This is the axon, and these are the myelin sheets. The myelin sheet, when it is formed by the oligodendrocytes, it is not complete. Look at the diagram. It is interpret here, right? So this interpret part is called node of Ranvier. This interpret part is node of Ranvier. So impulse from these neurons is passing either through this, but we think normally it is passing like this. No, it is jump from this node of Ranvier to this node of Ranvier, and from this node of Ranvier to this node of Ranvier. बहुत सीधी बात बता रहा हूँ. The nerve impulses transmit from the cell of the neuron. They comes out, and they are not passing continuously. They are not passing continuously. Rather, they jump from one node of Ranvier to another node of Ranvier. And this type of conduction of nerve impulses is called saltatory conduction of nerve impulses. So in myelinated nerve fibers, the impulses are saltatory conduction. And what is the saltatory conduction? Jump from one node of Ranvier to another node of Ranvier. And this is very fast. Follow? आप यहाँ से जंप करोगे और मैं नॉर्मली जाऊंगा, कौन जल्दी जाएगा? So this type of conduction is called saltatory conduction of nerve impulses, and that is the reason why the nerve impulse is passing fast in the myelinated nerve fibers compared to the unmyelinated nerve fibers. This is the diagram showing, look, this is unipolar, bipolar neuron, and look here, pseudo-unipolar, single process dividing into the axon and dendrite, and this is multipolar. This is the classification on the basis of process, and see this diagram. This is also commonly asked. On the shape of neuron, we classify the neuron into pyramidal, straight, fusiform, and look the diagram, you will understand. The pyramidal triangular in shape. The pyramidal neurons are triangular in shape and are present in cerebral layer of the brain, pyramidal cells, and pyramidal cells are seen only in the part of cerebrum. When we talk of the histology or microanatomy, teach you that cerebrum is consisting consists of 6 layers, and 6 layers are having the different type of the neuron fibers. So this is the pyramidal cells, and look here, the another is the stellate cells. The stellate cells is star shaped, and another the flash shaped cells. Look, the flash shaped cells, very important. The flash shaped cells, they are present only in cerebellum, nothing else. Flash shaped cells, just look this one, which is the common name of it is Purkinje cells. So Purkinje cells are the flash shaped cells, and they are present in the cerebellum. One layer of the cerebellum is of Purkinje cells. So once you see the Purkinje cells, identify the slide as of cerebellum. Stellate-shaped cells, these are present in the again in the brain. Then there is the horizontal cells and all. The horizontal layer is another the part of sixth layer of the cerebrum that I will tell you later on, not at present, because you will not understand. Look this part. These are the different type of the neuroglial cells. This is the fibrous astrocytes. This is protoplasmic astrocytes. And this is oligodendrocytes, and this is microglial cells, ependymal cells. Look this diagram, brain and spinal cord. The cranial nerves, 12 pairs, spinal nerves, 31. Look this diagram. You can understand what are the different. This is the pseudo-unipolar neuron. Process T-shape, pseudo-unipolar neuron. And this is bipolar, multipolar. Then I come to the part of peripheral nerve. The peripheral nerve, this is the transverse section. When we take the longitudinal section, in the center of the nerve, there is present axon. This axon is surrounding by the part of protoplasm that is called axolemma, and surrounding this axon there is outer part is of Schwann cells if the nerve fiber is myelinated, and this Schwann cell and their cytoplasm is forming the part of neurolemma. The point I want to tell you, peripheral nerve fiber, whatever the type, that it is part of the thoracic part, cranial part. These nerve fibers, most of them are myelinated. And what is the myelinated? That thing I am telling you. Axon. Axon is surrounding by the axolemma, and outside this is there is present Schwann cells. We know the purpose of Schwann cells. They are right, and outside these Schwann cells, there is present the Schwann cells cytoplasm, and outside the layer. So this part where the Schwann cell cytoplasm is present outside and the protoplasmic line, this is called neurolemma. Try to understand. You will understand betterly later on when you become surgeon or physician. If the neurolemma is damaged, then there will be nerve fiber will not be regenerated. So neurolemma is that part of the peripheral nerve fibers which give rise regeneration of the nerve fibers. If there is an injury, due to injury the nerve fiber is cut. But if the neurolemma is there, then regeneration will occur. Naturally it will take time, and the time is not fixed. So neurolemma is the important part of the nerve fiber. Now look this part. This is the spinal cord. It is again having the gray matter. This is the gray matter mass, and that is the white matter mass. And we divide this into dorsal root, and this is the ventral root, and this is the intermediate part. And the neuron which is present here, that is called interneuron. And another thing, as I have told you, dorsal root ganglion. The dorsal root ganglion, before that, try to understand. This is the skin. Here this is the pin, picking the pin. The sensation from the skin. They go through this green color now, reaching to the dorsal root ganglion. From the dorsal root ganglion, the fibers may relay here or may pass directly without relay. Try to understand. With sensation के nerve के through reaching to the dorsal root ganglion. If it is not powerful, it relay into the dorsal root ganglion. Okay, and the order is coming that you will take off or whatever you want. Then this from the dorsal root ganglion, the fibers they are reaching here. The thing which I am telling you, just touch किया पिन, मैंने हाथ हटा लिया. That I am telling you. Look here. The fibers are not, the sensation is not reaching to the central nervous system. Look here. They relay here interneurons. From the interneurons, the outer goes to the motor neuron. And they again reaching to the part of the skin or the muscle, which will contract and you will take off from the pin. This type of the arc is called reflex arc. This type of the arc is called reflex arc. Okay, so it is not necessary that every sensation reaches the central nervous system. Reflex arc is also doing the purpose. Look this part. This is the sensory part. Along the sensory part, this is the dorsal root ganglion, which is present here. And what type of the neuron is present in dorsal root ganglion? Pseudo-unipolar. Pseudo-unipolar neuron is present in dorsal root ganglion. And look here, this is the ventral root. In ventral root, the sympathetic ganglion is present. That I will talk, sympathetic chain, then you will understand. So where the sympathetic ganglion is present, like attached to the part of dorsal root. And this ventral root is again dividing into the anterior branch and lateral branches. And these are called the intercostal nerves. So, I am talking of the peripheral nerves. The peripheral nerves, they are 31 pairs. 8 cervical nerves, 12 thoracic nerves, lumbar, sacral, 5 and 1 coccygeal. Alright. So these are the 31 pairs of the spinal nerves. Out of these 31 pairs, the ventral rami of cervical nerves, lumbar, sacral. These ventral rami, they join with the adjacent ventral rami of the nerves. But the ventral rami of thoracic nerves, they are not joined. They are not joined. So the joining of the ventral rami in the cervical part, in the lumbar part, in the sacral part. Naturally, when one ventral rami is joined with the other nerve, we are saying these as plexus. जब एक से ज्यादा जोड़ जाएंगे तो plexus कहते हैं. And these plexus are in the body are cervical plexus, lumbar plexus, sacral plexus. The cervical plexus is formed by the ventral rami of C1, C2, C3, C4 and also taking part of few fibers from the C5. Okay, so this is the cervical plexus. This cervical plexus supplying the muscles, skin of the head and neck region and up to the shoulder joint. I am very simplified the things. The ventral rami of C1, C2, C3, C4 and some part of C5 joined together and forming the plexus that is called cervical plexus. The purpose of cervical plexus is supplying to the skin and muscles of the head and neck region and also the shoulder joint. The one important branch of cervical plexus is phrenic nerve. Is phrenic nerve. The phrenic nerve root value is C3, C4, C5 and that is supplying. Why it is important? Because it is supplying to the pleura of the lungs and pericardium of the heart and also diaphragm. So the phrenic nerve is very important branch of the cervical plexus. Then come to the brachial plexus, which you will read just now. Brachial plexus is formed by the C5, C6, C7, C8 and part of T1 fibers. C5, C6, C7, C8 and part of T1 fibers. They are forming the brachial plexus. The brachial plexus is supplying all the muscles of upper limb, which you will read just now. And the nerves, important nerves of brachial plexus are median nerve, musculocutaneous nerve, radial nerve, ulnar nerve. All these nerves, they are coming from the brachial plexus. Naturally, their root value will differ. Okay, so brachial plexus is supplying all the muscles of upper limb. Similarly, there is the lumbar plexus. Lumbar plexus is forming by L2, L3, L4, lumbar L2, L3, L4 and part 3 maybe L5. These are forming lumbar plexus. Lumbar plexus is supplying to the muscles of anterior abdominal wall, muscles of anterior abdominal wall and genitalia and anterior part of the lower limb. The nerves, important nerves of it is central nerve, obturator nerve, ilioinguinal nerve, iliohypogastric nerve, and genitofemoral nerve. So all these, they are supplying to the anterior abdominal wall and anterior part of lower leg. Then remaining is the sacral plexus S2, S3, S2, S3, S4. The nerves arising from sacral plexus, they are supplying to the gluteal region, perineum, and posterior part of the thigh, and also the lower limb. Sacral plexus, that is formed by the L4, L5, sorry, S1, S1, S2, S3, S4, and the sacral plexus give rise the important nerves which are supplying to the back of lower limb, gluteal region, and these are, the one is the sciatic nerve, and also the gluteal nerves, both superior and inferior gluteal nerves which are supplying to the part of gluteal muscles and the gluteal region. Pudendal nerve, PUD and DAL. Pudendal nerves. So these are the various plexes. Now I come to the part of, if we see the nervous system, the central nervous system, it is again having the part of efferent fibers and the neurons. Neurons are of two types. One, neuron which are present inside the brain, first order of neuron, and second order of neuron. As the neuron nerve fibers comes down, they synapse with the another neuron. And this junction, what is the synapses? The junction of the two neuron nerve fibers. And this junction is called synapses. And synapses is maybe the between axon of one nerve fiber to the axon of another nerve fiber. That is called axonic synapses. And another is the axon of one nerve fiber may synapse with the dendrites of other neuron fiber. That is called exodendritic synapses, which is very common. Exodendritic synapses is very common. Another is the axon may synapse with the cell body of the another neuron. Exosomatic, that is very rare. The function of the synapses is that at the synaptic cleft, the impulses come here, they stimulate this, and due to stimulation, some chemical substances release here. Some chemical substances release here. And these chemical substances which release here, they help in conduction of the nerve impulses. And these chemical substances which are released here, they are different types. And these are like acetylcholine, adrenaline, noradrenaline, also the histamine, dopamine, and another is gamma aminobutyric acid, GABA. G for gamma, A for amino, B for butyric acid, that is gamma. All these chemical substances, the purpose is same, that they transmit the impulses to the further neuron. So that is the conduction of this somatic part or the motor neurons and this. In case of the autonomic nervous system is having the two type of neuron, first order of neuron and second order of neuron. The first order of neuron of autonomic nervous system, sympathetic parts, they are named as preganglionic neuron. The first order of neuron in autonomic nervous system is preganglionic neuron, and second order of neuron is called postganglionic neuron. This autonomic nervous system be divided into two parts. Let's discuss this thing first so you will understand. Sympathetic part and parasympathetic part. The sympathetic part, neurons, they are located in the sympathetic chain on each side of the vertebral column. On each side of the vertebral column, there is sympathetic chain is present. And this sympathetic chain is consisting of about 22 ganglia. I have told you what is the ganglia. The neuron cell bodies present outside the central nervous system is called ganglia. Okay, the neuron cell bodies keep your tissue intact. The neuron cell bodies present outside the central nervous system is called ganglia. The ganglia in sympathetic nervous system and also present in parasympathetic nervous system. So, the sympathetic system, the ganglia are present in the sympathetic chain, and the number of the ganglia in sympathetic chain are about 22. They are about 22. So, preganglionic neurons, they are present in the sympathetic chain, and postganglionic neurons, they are present either close to the effector organ or maybe in the viscera. One thing. While in some ganglia, they are present along the sensory root of the spinal cord. These are named as dorsal root ganglia, which is also sensory. Another sensory ganglia, they are present along the cranial nerve also, not all, but fifth cranial nerve, seventh cranial nerve, fifth is named as trigeminal cranial nerve, having the three parts, and sixth cranial nerve, seventh, fifth, seventh, ninth, and tenth. Along these, the ganglia are present, parasympathetic ganglia, and they also present along the viscera. The part is this: the sympathetic ganglia, preganglionic fibers I have told you present in the sympathetic chain. The postganglionic fibers, as they leave the spinal cord, they relay into the part of sympathetic chain, or they may pass directly up and down, or relaying into the part of directly to the viscera. I have no diagram of that part, otherwise I will show you.